Good morning, Math 7. Today we are going to start the next chapter and focus on lesson 9.1 today. Chapter 9 is on surface area and volume, and section 9.1 specifically looks at surface area of prisms. So today we are going to talk about the surface area of prisms. On this slide you see multiple prisms, and you want to make sure you understand the concept of surface area. Okay, so if you were going to paint the outside of one of these boxes, surface area would be how much of the paint you would need to cover the whole box. Okay, so if you want to think of that example for surface area, I would suggest it. Okay, if you've also heard of volume, that would be like filling the inside. Okay, so let's go ahead and get started. We have a algebraic formula for the surface area of the prisms, which is 2 times length times width plus 2 times length times height plus 2 times width times height. Okay, so if you're looking at this box that we have on the right side, the length times width, okay, that is going to be the area of the bases. Okay, and then if you look at the other two, length times height, okay, and width times height, those are going to be the areas of the lateral faces. Okay, so essentially what we're doing here is we are taking the area of one of the bases, and we have to multiply it by 2. So if we have this base right here, we have to multiply it by 2 because the same exact area is on the bottom. Okay, so that's where you get that. Now, if we have length times height, we have our length here times our height. So think of that as the front. Okay, and then again we have to multiply it by 2 because it has the same area on the back side. And finally, I'm going to use green for this third one. Width times height, so we have the width times the height. This is the area of one of the sides, okay, lateral faces, and again multiplying it by 2 because the same exact area is over here. Okay, so we really just are trying to break it down. You see this diagram has is of this same rectangular prism if it was like folded down. Okay, so that kind of shows you where you're getting those areas from. So if we look at our first example, I want to make sure I do the areas of the bases first. Okay, so this is in red right here. Okay, and I see that this side length was labeled 3 down at the bottom, so I know this is also 3 here. This is 5, so this is also 5 here. Okay, so I'm going to do this in red. I know that the area of the base is going to be 3 times 5, okay, and we want to multiply that by 2, okay, because there are 2 of those bases. 3 times 5 is 15, okay, and when we multiply that by 2, we get 30, okay, so the area of both of the bases is 30 inches squared, okay. Next, I'm going to look at this front face, okay, so I am going to do the length times the height, okay, so we have a length of 3 and a height of 6, so we have 2 of them, so we do 6 times 3. Okay, so we have 2 times 18, and 18 times 2 is 36. Again, I multiply it by 2 because we have this back side face that is the same area. And finally, I'm going to use green. We have the width So 5 times the height again, I'm going to relabel it on this one, is 6. Okay, so if we are looking at this rectangle, and it is the same on this side. Okay, so I'll do this up above. We have 6 times 5, and we have 2 of those, so multiplied by 2. 2 times 30, and we get 60. So now what I have to do is add up 60 plus 30 plus 36, and I get 126 inches squared for the first surface area. Okay, I broke this example up into chunk by chunk. If you like to do this way and add kind of more so across, you can do that. I think it's easier when I just break it up into multiple parts. Okay, so my next one, I'm going to do the bases again first. This is my base here. It has a length of 2 and a width of 3, so I have to multiply that twice, so 2 times 3, 2 times 6, and I get 12 for the bases. Next, I'm going to do this front face. So it has a length of 2 and a height of 4. So multiply that by 2. We get 2 times 4. 2 times 8 equals 16. And finally, we have the side lateral face. So it has a width of 3 and a height of 4. So 2 times 3 times 4. 2 times 12, which is 24. So now I'm going to add up all the areas together, 12 plus 16 plus 24, and I will get 52 feet squared. Okay, we have one more example here, so hopefully by now you are catching on to the pattern, okay? I'm going to find this top base. It's going to be the same as this bottom base, which is 8 by 8, okay? So 2 times 8 times 8, 2 times 64, which is 128. Okay, next I'm going to do the front face, which is 5 times the bottom, which is 8, and so 2 times 5 times 8. It does not matter which order you do these in, just make sure you're getting all of them. So I get 2 times 40, which is 80. And finally, the side face, which is 8 multiplied by the height, another 5. Okay, so we already know 8 times 5 is 40. When we multiply that by 2, we get 80. So we actually have 4 similar faces in this one, okay, because we have 2 measures of 8, okay. Anyways, we have 128 plus 80 plus 80, and that is going to equal 288 meters squared. Okay, there's one more concept I want us to look at today. And the next thing in your notes is surface area of a prism. We are actually going to hold off on that for the next lesson, and we are going to find surface area of a cube, okay? So this is just like finding surface area of a rectangular prism, except this process is a whole lot easier because all of the faces are the same, okay? So if you count up all of the faces on this cube, let's do it together. We have one face, the back face, 1, 2, side, 3, 4, 5, 6. We have 6 faces. Okay, so what you really need to do is find the area of one face. Okay, so for example, this is going to be 12 times 12. And because we have 6 of the same faces, we can multiply that by 6. Okay, so 12 times 12 is 144. And when we multiply that by 6, we get that this surface area is 864 meters squared. Let's do 2 more examples because they are fairly quick and easy. We have 6 faces, and each face has dimensions of 0.5 by 0.5. Okay, 0.5 times 0.5 is 0.25. And when you multiply that by 6, because there are 6 faces, we get 1.5. The units on this will be centimeters squared. And finally, 6 faces again for this cube. You know it's a cube when all the length, width, and height are all the same. And we have to multiply 2/3 by 2/3. Remember, multiplication, we do not need common denominator, so we can just multiply across, and we would get 2 times 2 is 4, and 3 times 3 is 9. Okay, so 4/9. And again, we can multiply across, put 1 as a denominator for 6, and get 24/9. 24/9 as a decimal is equal to 2.6, repeating, and this is feet squared. Okay, so to sum up today, we looked at finding the surface area of a rectangular prism, okay? So sometimes this is hard to visualize. If you have a shoebox, you could get a shoebox out to show you the different sides and how there are 2 of the same faces on each rectangular prism, okay? So that is why we multiply each face by 2. And then we have to add them all up. We are going to look at triangular prisms next class, and we also looked at the area of a cube today. Remember, cube just meaning that all 3 dimensions are the same. We have 6 of the same faces, so we can just multiply it by 6. I noticed we missed one thing, so hopefully you're still listening. If we just wanted to fill in these blanks, this should be the lateral surface area of a prism is the sum of all of the lateral faces. Okay, just meaning that the surface area of any prism is going to be all of the surface areas of the lateral sides added together. Okay, have a good day. Let me know if you have any questions.